What's up, Formula Ed fans? Welcome back to the Engineer's Corner question. We are going to cover this vortex question, so let's dive right into it. You are reviewing this wing configuration and better understand flow behavior. In what direction will the left wingtip vortex rotate based on this diagram and perspective? Intuitively, if you don't have like an engineering background, intuitively you'll look at this question and you'll see a high pressure region and a low pressure region and an arrow going down like a vector, right? It's a force. So we have this high pressure loading up on the top of the wing and this low pressure region, but that high pressure loading, that airflow dumps off to the side. So it kind of has this horizontal direction. So as it's going horizontally and downward, it's going to create a rotation, a torque. So oddly enough, this answer was actually counterclockwise. Now I do have some clips of CFD that we can step through here, and I think you guys will benefit quite a bit from that and actually enjoy it a little bit more. So let's dive into the CFD a little bit. All right, so here is a nice clip of some CFD analysis done within Air and done by, I don't want to mess up his name, Nico Arce. I hope that's correct. If it's not, I apologize. But very, very informative analysis, right? So to go into the engineer's corner question and utilize the CFD for our affirmation or validation, we'll come over here, we'll take a look, and we'll see this flow in this particular region dumping off to the side, this streamline, these streamlines here, and you will see high pressure flow, right? High pressure flow coming off of this wing, and you'll see it dumping off over to the left sides on this wingtips, right? So it's got this horizontal aspect to it, but it's got a low pressure region over here, right? So this flow is like, oh, I'm going to go down, but I'm also going sideways. So it's creating this rotation, right? So we get this counterclockwise cool little vortex that you see here. And that is essentially the answer, right? We get a counterclockwise rotation. Now, CFD, of course, you're not going to always blindly use CFD, right? There is aspects of fidelity and validity behind a CFD simulation. So don't let me fool you with that. In this particular instance, we have pretty strong history and understanding of vortex generation off of wingtips and have some like theories and laws like Helmholtz law that kind of help explain vortex generation and how vortices behave off of wingtips. So this was kind of an intuitive aspect for most engineers, but if you are new to the motorsports arena or just not really well versed on the engineering aspect because you're not an engineer, well, here's a nice picture to help validate what that actually looks like and what this can eventually become. Now, I did post about turbulent flow or getting caught in turbulent flow and dirty air, right? We always hear about dirty air from the commentators and during the race. And some folks that are watching the race might not like, what does dirty air mean, right? It could mean a slew of things, or what does that actually entail? And oddly enough, this CFD analysis gives us a pretty decent perspective on what dirty air is. So if you're the trailing car behind this vehicle here, right? And we come over here, and this is kind of what dirty air looks like, right? We go from this beautiful, entry-free stream that's nice and straight, and obviously there's assumptions there, but we go from this beautiful entry flow, right? And then it's got to come across all the intricate aerodynamic geometries. It's got to come across the tires and all kinds of interesting aspects, right? And then after that, it eventually makes its way to the back and gets spit out, and ta-da, you get all this crazy flow that these wings, right, have to deal with now. So when an F1 driver gets a little too close to their opponent, that's the region where they have to begin to deal with dirty air, which costs them energy, right? Because it causes instability. It causes instability for them, and they have to work even harder now to maintain control of the vehicle. And that control comes at an expense, right? That comes at a cost. So this is kind of a rough idea of what dirty air may look like. And let's see if we can go lower here and get an image of the vortex. Let's see. So we get a little bit more coming off the body here. You'll see. So there are a lot of flow intricacies that feed into this, and you'll kind of see this guy here, right? These fences, right? These fences that are spinning. You see the vortex being generated there, the little vortice, and then it comes across the wheel. So there is a lot that goes on. Let's change our perspective here. Let's shift over. Let's see. There we go. A little bit more. There we go. Look at that. So we get a lot of intricate flow behavior coming off of these aerodynamic geometries, right? And even the wheels, right? And these guys back here that are trailing behind this car have to essentially deal with it. So it becomes quite a battle for them to come across this turbulent flow when they're close enough to deal with. So whenever you hear F1 commentators talk about dirty airflow and things like that, this hopefully paints a picture and hopefully gives you an idea and something to ponder on. And I think this will be an interesting one. And comment down below if you don't mind, because I would love to get your guys' thoughts on this. If F1 teams build their aerodynamic geometries for defensive aspects, like creating even more turbulent flow for their opponents that are trailing, do you think that's a thing, or do you think they just focus purely on optimizing for downforce and reduced drag, and maybe not worrying about causing problems for their competitor behind them? Maybe it's a countermeasure type performance, right? So if you guys don't mind, let me know your thoughts on that. You know, what's your take on that position, and if you think teams would actually spend money on that or not. I would love to hear the group's thoughts on this, if you don't mind sharing. And hopefully this Engineer's Corner question was informative and fun. There's going to be more to come, and I do have some interviews scheduled with technical experts in various domains, so please stick around, subscribe, get involved, because this YouTube channel is going to be expanding. So I hope, again, this was informative and enjoyable, and looking forward to chatting with you all later. And like I said, drop your thoughts in the comments. Would appreciate a conversation, and we'll talk later. Take care. Formued out.